Okay, so do we have our answer here for this one? This is one of the kind of problems that I think you guys struggle with immensely. You're just reading the words and having to write an equation from it. So I'm going to show you how to do it. The length of a box is. So length, I'm going to use the variable L to represent length. Anytime I see the word is in a math sentence, what do I think of? Is means equals. Length is, that means length equals 3 less than twice the width. So anytime you see less than, that means we are subtracting, and you have to subtract the 3 at the end. Less than means that number goes at the end of your statement. So less than 3, or 3 less than, means I'm going to subtract 3 from the end. Twice the width. So twice the width would be 2W. That's it. Okay, so very quickly, the end of the lesson yesterday, I didn't do the most awesome job with you guys. So let's try to recap that very quickly before we go on to today's lesson. So the big thing that we were looking at is if I had two events, let's call them A and B. So the probability of A or B happening. So for instance, the last example yesterday was the probability that they can do the taco tongue or they can do the evil eye. Right? It was one or the other. That's A or B. What we're going to do, here's the formula for the probability of A or B. You find the probability of A happening. You add the probability of B happening, and then we have to subtract the overlap. So in this class, did I color in the Venn diagrams and show you where it had overlapped? So remember, where those two overlap with each other, we have to subtract that because it's been counted twice. So what we'll do is we will subtract the place where A and B intersect. And that's what that symbol means. That's the intersection of A and B. So this is the formula when I have the probability of A happening or B happening. All right? So you need to know that formula. Anytime you see the word or, think you have to subtract the overlap. Now, if you'll remember, we had an example before that had the word or, but there was no overlap. Do you remember me coloring in that Venn diagram where the blue and the green never touched? So sometimes there is no overlap. So I don't have to subtract it. But if there is an overlap that gets counted twice, you have to subtract that probability. So here, our first question that we're talking about today is bringing up that or statement again. So the probability that they said yes, they could taco tongue, or they said yes, they could evil eyebrow. So because there's an or statement, that means I need to subtract the overlap. So this was y'all's table. Let's don't forget to total it. Okay, so let's do the totals. So the total for yes taco tongue was 14. The total for no taco tongue was 3. And let's see, the totals for yes evil eyebrow was 12. No evil eyebrow was 5. So those both total to be 17. So what's the probability that they said yes, they could taco tongue? There would be 14 out of 17, right? 14 people said yes, they could taco tongue out of the 17. Or it means I'm going to add the probability of yes, evil eyebrow. So yes, evil eyebrow is here. It is 12 out of 17. But now then, what did we just go over? Because this is an or statement, we have to subtract the overlap. So who are the people that said yes to both? Yes to taco tongue and yes to evil eyebrow. That would be these 12 people, right? So again, your class was a little funny because you had nobody in this column, right? That's what makes these two numbers be the same. Because you had no one that could evil eyebrow but could not taco tongue. Okay. So if I add these up, the plus 1217 and minus 1217, those cancel out. And I'm left with only 14 over 17. So today, we are given a new situation. And I just said the word. This shows how my brain's just terrible. So given that a person is selected, yes, evil eyebrow, what is the probability they are yes, taco tongue? So before, we were saying given that the person was a student in the class. We're no longer looking at all students. We're only looking at a subset of the students. What subset are we looking for? Only the people who said yes to evil eyebrow. So it's kind of like the only thing I care about is this row. This is all I'm looking at. So here's how we would write this. This is the probability. What's the event we're wanting to happen? We're wanting them to be yes to taco tongue. Right, that's still what we're looking for. Yes for taco tongues, given, so we put a line here. That line stands for given. And what are we given here? We're only looking for people who were yes, evil, eyebrow. So what that really means is you're changing the number in the denominator with this given. So when I make my fraction, the only people I'm looking for are the ones that were yes, evil eyebrow. So how many people were yes, evil eyebrow? 12. From this number right here. So that means 12 is my denominator. And now how many that said yes to evil eyebrow also said yes to taco tongue? 12. So the probability that if I'm only looking at the people who said yes to evil eyebrow, that they could also taco tongue, that is 100%. Or 1. Right? It tells me write the answer as a fraction, a decimal, and a percent. So that's what your guys' data would look like. All right, so when we write our formal definition, hopefully we all get that right. The probability, what are we wanting to find? The people who were...
No to evil eyebrow.
That's incorrect.
Well, yes to taco.
We're wanting to find people who were yes to taco tongue, given they answered no to evil eyebrow. Right? The given statement is the subset. And so that's the one that goes at the end. Does everybody understand that? How we would write that?
The yes always goes first.
Huh?
So the yes will always.
No. Whatever you're given has to go second. That's the way you need to think about it. Because given is the only row or column we're looking in. So here, we are given the person said no to evil eyebrow. So how many people said no to evil eyebrow? 5. Right? Only 5 people said no to evil eyebrow. So my denominator, my set of all people that I'm pulling from, is only these 5. I'm only looking at the ones that said no to evil eyebrow. What's the probability that one of these 5 people said yes to taco tongue? So how many of these 5 said yes to taco tongue?
2.
Only 2. Right? Because I'm only looking at this subset. Only this column. So what's the probability here? It would be 2 over 5, which is
40.
40%. or 0.4, right, as a decimal. We can say two events are independent of each other whether or not one event has occurred does not change the probability of the other event occurring. So are the events yes taco tongue and yes evil eyebrow independent of each other? Okay, so here's what they're saying. Look at your number 2. What was the probability that someone could taco tongue? 14 over 17. Turn that into a decimal and a percent. So 14 over 17 would be
82.3.
so 0.823 or 82%. So the probability if I pick one of you at random that you can taco tongue is 82%. Now, if I'm looking at only the people who could evil eyebrow, what percent of those could do the taco tongue? That's your number 3. 100% of them could taco tongue. So are those the same? No. And when I look here at this percentage for your last one, what about the people who couldn't evil eyebrow? How many of them could taco tongue? It's 40%. So if they are independent events, all 3 of those probabilities will be the same. Let me say that again. If they are independent events, your number 2, 3, and 4 will all have the same probability. So did they all have the same probability? No. So are they independent? No. That's your explanation. So we would say because the probabilities is different when given a subset of the population comma these events are not independent. Okay, so when I look at A, are we ready to go over these? What did y'all get for the probability that a person chosen at random can taco tongue?
80%.
Well, what fraction did you get? Let's start with the fraction.
480 over 600.
So the people that can taco tongue is 480 out of 600 total. Right? This is the total people who said yes to taco tongue. You guys understand that? I'm looking at this whole row. These are the people that said yes to taco tongue. There's 480 in that row. Out of 600, so this fraction will reduce to 4/5, which is 0.8, which is 80%. Right, depending on how you want it written. Fraction, decimal, or percentage. Are there questions about where to get that fraction from, that probability from? That's not that challenging. We need to have that one down. Right, that's what we've been working on for 3 days now. A basic probability. Now for B, we're looking at the probability that they said yes taco tongue given that they were yes evil eyebrow. So because this is my given, I'm only looking at a subset of the population. The only people I'm looking at are the ones that said yes evil eyebrow. And that is these people right here. They're the ones that said yes evil eyebrow. So how many total people are there? 200. That's my denominator. And how many of those 200 said yes to taco tongue? 180. So that's 180 over 200, which is 9 over 10. which is 0.9 or 90%.
No.
Which part are you confused on?
Accept it.
I added it, I don't know, I just.
Like you got the wrong fraction?
No, I just got the wrong numbers, like I did 200 and 600.
Okay.
But
So-
I get why it's not.
So what we did, the new thing we learned before you're in here, this is a subset. It means we're not looking at all the population anymore. We're only looking at this part of the population. So only the ones that said yes, evil eyebrows, that's my total. And how many from here said yes to taco tongue? That's the 180. Only a subset of the population. Are there any other questions on B? How many got that right without?
Oh, I'm good.
Not many?
Oh, wait a minute.
So what are we confused about? I mean, that's okay.
I did like the total, like I had like 180
I'm still on this.
over like, what's the thing? 480. You know what I'm saying?
Get it over this one.
Yeah, let's trade this.
I read it as yes,
Use
taco
each pen so
tongue.
you can think of each
You read it as or?
Yeah,
This is not an or.
Yeah.
My real pen.
This, if it was or,
yeah.
Look.
we would do or. But this is need, this is given.
Damn it.
So we're only looking at a
So it's like
subset.
yes,
On the
no,
true
so
way
it's
it
taco
goes.
tongue.
So it's
over
like,
equal
it's like
eyebrow.
in here, if I said, what's the probability that someone could taco tongue given they were a male? Well, I'm eliminating part of the class from the get-go, right? I'm narrowing it down. It's no longer everyone I'm looking at. I'm only looking at males. And then I want to know how many of those can taco tongue.
So the second option or whatever is always the denominator.
This says given, yes. However, this is a subset. So this is the number of people you're looking for in total. That's going to be the denominator. The ones that said yes to evil eyebrow. You did it backwards?
I did like number 2 for number 1.
Gotcha. So for C, what subset are we looking at? Only the ones that said no to evil eyebrow. So I'm looking at this column, right? Those are the ones that told me no evil eyebrow. So how many total are there that are in the no evil eyebrow? 400. And how many of those 400 were yes taco tongue? 300. So this would be 3/4, which is 0.75, which is 75%. Questions? So is yes taco tongue and yes evil eyebrow, are they independent of each other? No, because these percentages did not match. Right? That means they are not independent. Okay, so now what it wants me to do here, it wants me to fill out the table as if the events were independent. So look back at your answer to 6A. The probability of somebody answering yes to taco tongue was what?
80%.
80% or 0.8. So we want that 80% to be true everywhere. So we want the people that said yes to taco tongue here to be 80% of the subset. Okay? So in this column, they have to add up to be 200. Well, I want 80% of them to answer yes. So how can I find 80% of 200? 80% of 200. Do you guys know? You do multiply. Whenever you hear the word of in math, of means multiply. So if I'm finding 80%, that's 0.8 of 200, it is 160. So we would want this spot to be 160. So how many would have to answer no taco tongue in this column? 40. because it have to total to be 200. Right? Do we follow? 40 here. Now, how many people do we want to be yes taco tongue in this column? We want it to be, no, how many do we want to be yes taco tongue in this column? We want to have 80% still because we want it to be consistent. We want it to be independent, right? So I need this one, this box to be 80% of 400.
320.
So 0.8 times 400 is 320, which means what does this box need to be? 80. So we found that they total correctly in this direction, right? Now let's see if they total directly this way. What is 160 plus 320? 160 plus 320 is 480. What is 40 plus 80? 120. So it totals correctly the other direction. I just had to think about it in one direction, but it will work out correctly in the other direction if they are independent. Okay? That's what I was trying to do over there, and I kept getting decimals because I didn't pick good numbers. Right? Sorry. So here, what's the probability in this table that the person said yes to taco tongue? Yes to taco tongue. What's my denominator? How many total people am I looking at?
600.
I'm looking at everyone. It's 600. And how many of them said yes to taco tongue?
480.
480. Which is 80% or 0.8 or 4/5.
I'm taking a wild guess saying everything's gonna be 8%.
Well,
Really?
let's work it out.
Uh-oh.
Or just don't learn it and just say, ho, it's all the same. And then you're going to miss a bunch on the test. So here, if I'm looking at the probability that they said yes taco tongue, given I'm looking at the yes evil eyebrow people. So what's my denominator?
Yes, evil eyebrow.
The people that are in yes evil eyebrow,
200.
which is 200. Right, I'm looking at this column. So the ones that are yes evil eyebrow are 200.
I don't even know 200 people.
Go look around the school. How many of them are yes taco tongue?
60.
160. Yeah, there's 1,200 students in the school. 160 over 200 is 4/5, which is 0.8, which is 80%. Sorry, getting kind of sloppy at the bottom of the iPad. Hopefully you can read that.
I can read it. I've known you for long enough.
And then when I look here at the last one, what's my subset I'm looking for? Only the people that said no evil eyebrow. So how many is that?
400.
400. And out of those 400, how many were yes to taco tongue?
About
320 of those 400 were yes to taco tongue. Just kind of making a little more sense, maybe?
really sad if we did this all wrong and the last one was a 80%.
So 320 over 400, that reduces to 4/5 or 0.8
Well,
or 80%.
did you record this last one?
I did. So now,
Will or not? Hear my voice.
number 9, it says, what do you notice about your answers in number 6 and number 8?
The 8 is.
6 is not independent.
And 8
8 is.
Yeah, because the percents match on
So 6 is not independent, 8 is independent, because all the probabilities reduce or simplify to be 80% for all of those. So that's what you're looking at in number 9. Give me just one second. Okay, when the events are not independent, all three probabilities are different. When they are independent, all three of the probabilities are equal. So let's look at number 10, taco tongue. And let B be the people that said yes, evil eyebrow. So here's what we would say. If all the events are independent, then if I found the probability of A, it's the same even if I take a subset, right? So that means it's equal to the probability of A given B. Give you a minute to take that in, see if you understand what it's saying. If the probability of A is the same as the probability of A given B, then they're independent, right? Because we have the same probabilities. But we also have to check a third probability. We got to check the people that said no to B, right? The ones that were no evil eyebrow. So how would we write that?
Probability of B given A.
How can I say the people that answered no to B? It's not quite negative B. It is something we learned about the opposite of B yesterday.
Oh, the C.
The complement. So the probability of A given B's complement. So we'd put a little C up there. And what that complement means is not in B. Right? They answered the opposite of yes to B, which would mean they answered no to B. So again, you could think about it as a negative or a not.